My name is Domenico Pratichizzo from University of Siena and Istituto Italiano di Tecnologia. I lead a laboratory, a group of people working at SIRSLab, and it is for me a pleasure to be part of this workshop organized within the Facebook AI research strategy on the future of tactile sensing application and challenges. In particular, I will focus my vision on wearability and the social interaction mediated by wearable haptic technologies. The first concept that I will talk about is the wearability. In particular, in 2013, with colleagues within a huge project in Europe called Wearable that I had the honor to coordinate, we went towards the highly wearable haptics concept. In particular, we went from grounded haptics to exoskeleton to something that has a fingertip pulp design, a thimble design with mechanism inside. An idea of the device, this is a work done with a group of Miguel Tadui, where we optimized the design of the fingertip device of the thimble with the haptic rendering algorithms in order to render the force at the fingertip by orienting the platform according to the contact point with the virtual sphere that you can see in the video. And you can see how compact and is this kind of concept. So we can go around without being constrained in our workspace. Of course, we are missing something. We are using only cutaneous sensation more than kinesthetic perception, because this is not a kinesthetic device but a cutaneous device. Since then, we implemented in the same packed version of the device not only the skin indentation but also vibrations with the piezoelectric motor and also temperature. You see the ice in the glasses. With the temperature we implemented a Peltier cell in the same device. So this has been done in the laboratory and then became a startup that I co-founded with two PhD students in my lab, Guido Gioioso and Giovanni Spagnoletti, and together with a company, Enovia. And this is the form factor that we have now. This is the touch diver by WeArt, and we use this touch diver to do this nice virtual reality interaction where we are simulating for training laboratory where we work with vials. You can feel the bottom here, for example, by tapping the bottom, you feel the skin indentation, but also when you hold an object, you feel the skin indentation of the three fingertip device, and you have the sensation of holding the object. And then you put in this area, for example, and you take some material and you scrap the material, you remove the material. Now in this case there is a rotating platform that removes the material, and you feel the vibration at your fingertip. So there is the vibration interaction. In this case there is the grasping interaction. There was the key interaction by fingertip skin indentation. Giovanni, in this particular case, will open a fridge by tapping the keys to unlock this door, and he will open the door, and I'm feeling here the keys, and when the door is open you will touch a very cold device and you will feel the temperature. If you try it, you will be really impressed the way we were able to control the Peltier cell to have the very low, very good transient. Okay, well, one of the main issue in highly wearable haptics with fingertip device, with thimble device, is, for example, in this case, when I show you the interaction of a virtual hand with an object, is that if you have only fingertip device, you cannot stop your hand moving. Actually, you stop it because you feel something at your fingertip, but there is no kinesthetic, there is no exoskeleton, no kinesthetic device that stops you moving. So we wanted to improve this idea, and recently in my lab we had this idea how to stop the motion of our fingers if we have only thimble device. Well, the idea was quite nice because we thought the idea was to use our own body to stop the fingers. in particular by accelerating, actually by delaying the velocity, the speed of the fingers in the virtual reality. When you have the impact in the virtual reality with the object, basically you are touching the other finger of your hand. So, and you feel the other finger of your hand, but you perceive like it was the object, because your brain is tricked by the virtual reality flow in the image. So we found this result very interesting, and so we are trying to imagine how our body can help recovering some of the kinesthetic feedback while using cutaneous feedback. Well, up to here we presented Thimble, and the Thimble is a nice form factor for virtual reality, because basically the fingertip pulp is the equivalent of our eyes for touch, of course. And if you are using some device like the Oculus and you stop, you cannot see anything basically unless you have a camera. Then, since you have the flow of the information stopped for the vision, you can also allow to have the fingertip completely closed and you don't perceive anything with the Thimble device. But if you want to go for augmented reality, and if you want to see also directly the real environment by using your eyes, then you probably want to have your fingertip pulp free, because you want also to touch something and have some additional information on top of it. So I think that the ring factor is the right form factor for augmented reality. We worked a lot on that. We published paper showing the temperature in the ring. We were the first with a paper on transaction haptics to show how the ring could be used for augmented haptic interaction. For example, in this video you see that we are grasping with the naked fingertip pulp the real object, plus on top of it there is a virtual object, the blue one, that we were able to perceive by using the ring force interaction. The ring were applying tangential forces to the base of our finger, and we're replicating in some way the force in this mixed reality environment. Concluding, it's for me important to underline the concept of highly wearable devices with the Thimble and rings, for example, to be able to interact with more freedom in the virtual reality and augmented reality. As you know, Facebook is going towards this metaverse. This kind of device can be really interesting to interact even haptically with the environment. Well, there is another application that I would like to tell to you about wearability, is that this wearable haptic device can also be used to improve the interaction between humans, okay? Not only in virtual reality and augmented reality. For example, in this case, we have two friends, one on the left and one on the right, that are using two anklets, and these two anklets are able to record the impact with the floor, and also to provide feedback to the anklets. So basically, the lady on the left is walking, and while she walks provides feedback on the ladies on the right that perceive the feedback of the other runner. So I can be in Siena and my friend can be in Milano, and we can walk together by transmitting the impact through tactile feedback. There is a nice result that we recently published, and we showed that we both of us find a consensus in terms of the speed of the rate of our steps, because of course this haptic interaction interact with our sensory motor control of our legs and allow us to go coherently at the same speed. So there can be many applications we used. We are exploring medical applications, social application, and other things. Another thing that I would like to talk about is exactly the same concept, but for the nodding. For example, two people, when we watch each other, we have the concept of nodding is very important to have a consensus, to tell the other people that I understood what he was saying. Of course, when I walk, when I'm over a phone call, I cannot use the nodding, the visual nodding basically, because I don't see the face of the other subject. So we invented very recently a pair of glasses that is able to provide feedback that can be either on the shoulder or on the glasses, and also of course measure the head nodding and shaking. And in practice, when Nicole on the left do nodding, okay, so there is this motion is detected by the accelerometer and is sent to Tommaso on the right towards either feedback on the shoulder or feedback in the glasses.
Repeat them to me, is that okay?
Okay, perfect.
Yeah. All right, so here goes. First you need...
To conclude, I presented my vision on wearability in haptics and on how these highly wearable devices can be used in social interaction. Thanks for your attention.